Good morning, my dear students. So here is your Seema ma'am with third lecture in series of chapter integers. Division of integers. We know that division is the inverse operation of multiplication. Let us see an example for whole numbers. Since 3 into 5 is 15, so 15 divided by 5 is 3 and 15 divided by 3 is 5. Similarly, 4 into 3 is 12. That gives 12 divided by 4 as 3 and 12 divided by 3 as 4. We can say for each multiplication statement of whole numbers, there are two division statements. Can you write multiplication statement and its corresponding division statement for integers? Observe the following and complete it. From the previous table, we observed that minus 12 divided by 2 is minus 6, minus 20 divided by 5 is minus 4, minus 32 divided by 4 is minus 8, and minus 45 divided by 5 is minus 9. We observe that when we divide a negative integer by a positive integer, we divide them as whole numbers and then put a minus sign before the quotient. We also observe that 72 divided by minus 8 is equal to minus 9 and 50 divided by minus 10 is minus 5. 72 divided by minus 9 is minus 8 and 50 divided by minus 5 is minus 10. So we can say that when we divide a positive integer by a negative integer, we first divide them as whole numbers and then put a minus sign before the quotient. In general, for two positive integers a and b, a divided by minus b is equal to minus a divided by b, where b is not equal to 0. Properties of division of integers. Observe the following table and complete it. What do you observe? We observe that integers are not close under division. Statement minus 8 divided by minus 4 is equal to 2. Result is an integer. Statement minus 8 divided by 3 is minus 8 by 3. What is the inference here? It's not an integer. We know that division is not commutative for whole numbers. Let us check if for integers also. You can see from the table that minus 8 divided by minus 4 is not equal to minus 4 divided by minus 8. Is minus 9 divided by 3 the same as 3 divided by minus 9? Is minus 30 divided by minus 6 the same as minus 6 divided by minus 30? Can we say that division is commutative for integers? No. Like whole numbers, any integer divided by 0 is meaningless and 0 divided by an integer other than 0 is equal to 0. That is, for any integer a divided by 0 is not defined, but 0 divided by a is equal to 0 for a not equal to 0. When we divide a whole number by 1, it gives the same whole number. Let us check whether it is true for negative integers also. Observe the following. Minus 8 divided by 1 is minus 8. Minus 11 divided by 1 is minus 11. Minus 13 divided by 1 is minus 13. This shows that negative integer divided by 1 gives the same negative integer. So any integer divided by 1 gives the same integer. In general, for any integer a divided by 1 is equal to a. What happens when we divide any integer by minus 1? Complete the following table. Minus 8 divided by minus 1 is 8. Minus 11 divided by 1 is minus 11. 13 divided by minus 1 is minus 13. What do you observe? We can say that if any integer is divided by minus 1, it does not give the same integer. Can we say minus 16 divided by 4 in bracket divided by minus 2 is same as minus 16 divided by 4 divided by minus 2 in bracket? We know that minus 16 divided by 4 in bracket divided by minus 2 is equal to minus 4 divided by minus 2, that is equal to 2, and minus 16 divided by 4 divided by minus 2 in bracket is equal to minus 16 divided by minus 2, that is equal to 8. So minus 16 divided by 4 in bracket divided by minus 2 is not equal to minus 16 divided by 4 divided by minus 2 in bracket. Can you say that division is associative for integers? Definitely not. What have we discussed? Integers are a bigger collection of numbers which is formed by whole numbers and their negatives. These were introduced in class 6. We have studied in the earlier class about the representation of integers on the number line and their addition and subtraction. We now study the properties satisfied by addition and subtraction. Integers are closed for addition and subtraction both. Addition is commutative for integers. Addition is associative for integers. Integer 0 is the identity under addition. We studied how integers could be multiplied and found that a product of a positive and a negative integer is a negative integer, whereas the product of two negative integers is a positive integer. For example, minus 2 into 7 is minus 14 and minus 3 into minus 8 is 24. Product of even number of negative integers is positive, whereas the product of odd number of negative integers is negative. Integers show some properties under multiplication. Integers are closed under multiplication. Integers are commutative under multiplication. The integer 1 is the identity under multiplication. Multiplication is also associative for integers. Under addition and multiplication, integers show a property called distributive property. That is, a into b plus c is equal to a into b plus a into c, where a, b, c are three integers. The properties of commutativity, associativity, and addition and multiplication and the distributive property help us to make our calculations easier. We also learned how to divide integers. We found that when a positive integer is divided by a negative integer, the quotient obtained is negative. Division of negative integer by another negative integer gives a positive quotient. For any integer a, we have a divided by 0 is not defined. A divided by 1 is a. Now, your today's homework is exercise 1.3 from page number 14, chapter 1, integers. Now here is the solution of the last exercise 1.2, which was given as homework on 14th of May. Question number 2 says find the value of first part 3276 into 3 minus 3276 into 2. Most of you have done it in a simple way, directly multiplying and finding the answer. But since we studied how to make our calculation easier, we have to use the property. Here we will use distributive property, according to which we will take 3276 as common in the bracket 3 minus 2. 3 minus 2 will be 1 and 3276 into 1 will be 3276. Same way third part is done. Question number 3 says verify the following. So here you have to see LHS is equal to RHS or not. First part 23 into 7 plus of minus 2 in the bracket is equal to 23 into 7 plus 23 into minus 2. When we will solve LHS, we will get 23 into taking 7 plus of minus 2 will be 7 minus 2, that is 5, and 23 into 5 will be 115. On the right hand side, 23 into 7 will be 161 and 23 into minus 2 will be 46. Now 161 minus 46 will be 115. Therefore, LHS equals to RHS, hence proved. Question number 4. Determine the integers whose product with minus 1 is. First part was 23. Let us say the integer is x. According to question, x into minus 1 is 23. Therefore, x will be 23 divided by minus 1 and thus we will get the value of x as minus 23. Same manner you can do the other parts. Question number 5. Using convenient grouping evaluate. Now here again most of you have done the mistake. You are simply multiplying and giving the answer. Question is saying using convenient grouping. So you have to see how your calculations become easier. First part, minus 5 into 19 into minus 16, minus 5 into minus 60 into 19. This is using associative property. Minus 5 into minus 60 will be 300. Now 300 into 19 is 5700. Third part, 97 into 25 into minus 2 into minus 4. Here 97 into minus 2 into 25 into minus 4. 97 into minus 2 is minus 194. 25 into minus 4 is minus 100. And then minus 194 into minus 100 is 19,400. For question number 6, some of you are not getting left hand side and right hand side equal. Please remember and do your calculations properly. For every question you will get left hand side is equal to right hand side. That's all for today. Thank you.